The non-iterative transient solver is one of the biggest additions to Flownex 8.14. The previous versions of Flownex only included the iterative solver, which was used for transient runs. The iterative solver uses an iterative process to reach a converged result based on the convergence criteria specified by the user. This approach is ideal for simulations with large time steps. However, for simulations with small time steps, such as control studies, more processing power is needed, which ultimately causes slower transient runs. This new non-iterative transient solver does not require an iterative process for each time step. It solves the same physics as the iterative solver but allows non-iterative processes to occur. The non-iterative solver increases the solving time substantially, which is beneficial for large systems that need to be modeled for a prolonged amount of time. Users can also switch between the iterative and non-iterative solver before and during transient runs. This can be done by either using the transient solver settings, which can be found under the flow solver section in the solvers tab on the right, or by using a direct toggle between the solvers, which has been added to the home ribbon. To demonstrate the capabilities of the non-iterative solver, we will look at an RS-25 rocket engine network which has been presented in previous webinars. The network houses several components including low-pressure turbopumps, high-pressure turbopumps, and a couple of other branches throughout the system. This network has been chosen for the demonstration because all these components are working independently, which means that a lot of processing power is needed to simulate the setup in a transient run. So first we will set the network to solve using the iterative solver. We can do this by navigating to the Solvers tab and then selecting the flow solver. In the flow solver properties, there is a section for the transient solver settings, where we can set the transient solver to the iterative solver. As mentioned previously, these transient settings can be found in the home ribbon. Here you can see that the setting can be changed for either the iterative or non-iterative solver. To begin the transient, the network will first be solved in steady state. We can observe the speed of the simulation on the graph. We can then click on the Run button to start the transient simulation. As you can see, it takes quite some time to get the solution and for each time step to converge. If we look at the solver time, it takes roughly about 1.5 seconds per time step. Now let's observe the transient simulation using the non-iterative solver. We can first load the snap to return the initial inputs for the network and solve it in steady state. Then we can change the transient solver from iterative to non-iterative and run the simulation. As the network runs, you will notice that the simulation speed has increased considerably. The solver speed is now between 0.25 to 0.3 seconds, which is 5 times faster than it was for the iterative solver. Therefore, the non-iterative solver does improve solving speed, particularly for extensive interconnected systems that struggle to solve. Learn more about Flownex at www.flownex.com and join our discussion on LinkedIn and YouTube.